Good evening, guys. By the time you see this, I'm not sure what time will it be. So this video is for grade 10s. This is a revision video about financial mathematics for grade 10s. So these are some of the things that you did in grade 9. So here we go. So firstly, we have you have the simple interest. I'm sure you all remember the simple interest, and then we have the compound interest right there. I hope you remember the compound interest. So now, with the simple interest, the formula was more often this way, right here. And with the compound interest, your formula used to be this way, right there. Right. So now, in that case, like I said, I'm sure you're all aware now about the difference between the compound interest and the simple interest. So here, from the formula, we know that A represents the accumulated amount. The accumulated amount, it's the amount of money that you will get after a certain period of time. So as years move by, your principal amount, this one, your principal amount keeps on accumulating more money. After a certain period of time, then it becomes A, your accumulated amount. We call this the accumulated amount because over the years, this money has gained several interest, let's say so. And then we have I, as you see I there. I is the interest. Where is I? Right here. I is the interest, and we write this as a decimal. So we usually say, whenever a question says calculate for us the interest rate, we are looking for the percentage. And this I, we need you to write it as a decimal all the time. So which means when you substitute right here in your formula, we need this as a decimal. If you don't write this as a decimal, write this as a percentage. As a fraction. For instance, if I said 4%, you're going to substitute this I as 0.04, which is a decimal, or you're going to substitute this I as 4 over 100, which is a fraction. That's how we do it, right? This is the only way, guys, you can ever get marks on an exam. And then we have N, and then we are saying N represents the number of years. So this is the number of years. When we say 36 months, how many years is that? That's 3 years, right? And then when we say, sometimes there is this question they might say 18 months. Calculate the radar for 18 months. And then we are expecting you that you are going to think about it that, okay, this is actually N in years, right? So 1 year is around 12 months, right? And then plus another 6 months, this is like half a year. So what we are talking about here, we're talking about 1.5 years when we say 18 months, right? So you should think about that very clearly. And when you say 3 months, which means in your formula there, whenever you're replacing N, you're going to replace N as 3 months over a year, because it's a fraction. You don't write 3 or 0.3. No, you write your N as 3 over 12. All right, 3 months out of the whole year, or 3 months out of 12 months. You will see that if it appears, that question here. And then here I have a little graph right here. I hope you can see the graph. Where is this? Yeah. Hope you can see this graph right here, whereby it shows the account balance. Oh, yes. Before I move on to this, please don't forget the difference between the simple interest formula and the compound interest formula, whereby we know that the compound interest formula, it has an exponent of N, whereas in the simple interest formula, we multiply the N with the I, right? So now, here, what is the monetary difference between the compound interest and the simple interest formula? When money is compounded and when money accumulates through simple interest basis. So you see this blue line here. This is simple interest. So this shows here that at 0 years, the amount of money that is there in terms of simple interest and compound interest, it's more or less the same. After like 5 years, you would get the same amount through roughly the same amount for simple interest and for compound interest. And then as we go by, this compound interest now, it grows exponentially. It starts being above the simple interest graph, which means now through a short-term period, the compound interest and the simple interest, they almost grow almost at the same rate. But through a longer period of time, the compound interest increases massively compared to the simple interest, right? So that's what it is there. Let's scroll down a bit. So here's a question here. It says, calculating the value of A. What is A? A is the accumulated amount. So here it says, now here's what I want from you. Let me choose a different colored pen. Every time you read a question, I need you to decide what is that. Okay, so it says 5,000 is invested. 5,000 is invested. This is the current amount, right? So let's call this the principal amount. Oops. Let me fix that quick. Let me fix that right there. Yeah. Okay, it says 5,000 is invested. So this is the principal amount, unless maybe they tell us something otherwise. So far, this is the principal amount. In the bank, calculate using the appropriate formulae, the accumulated. Calculate the accumulated, which means what? A is unknown. That's what we are looking for. So we have P, which proves our point now. After 3 years, what is 3 years? 3 years is M. The total interest received is the interest, and the total interest received. Yeah. They want you to calculate the accumulated amount and the total interest received. Right. Okay. And then now it says if the interest rate is either this or that. So let's see if we can find those ones out. So what they are looking for, they are looking for the accumulated amount. 1. Number 2, they are looking for the interest received. So if this person is investing 5,000, how much more money will they gain on top as a form of interest? All right. So now let's do that quick. Let me choose a pen right there. I hope it will be visible. So here we're working with what? Simple interest. So which means I use the formula A is equals to P 1 plus I raised to N. Simple as that. Let me choose a lighter pen or a slimmer pen. Is it a slimmer pen or a lighter pen? Let's hope this works. And then so A, okay, perfect, is equals to, what is my principal amount? My principal amount is 5,000. And I have 1 plus, and remember, how do we write the I? We write this this percentage as a decimal or as a fraction. So I'm going to write here 0,0375 multiplied by what? By the N, because this is the simple interest formula. So I multiply by the number of years. We said how many years? Here it is, 3 years. Multiplied by 3. Then A is equals to, let me grab my calculator quick. Okay, so the accumulated amount that I get, it's 5562,5. 5562,5. Let's write that down. Boom. 5562,5. But then we are talking about money here, so which means I have to include the rands symbol because of us calculating in rands right there. And then again, the question paper will most likely say to 2 decimal places. When it says comma 5, it means it's comma 50. Easy as that. So now they want us to calculate the same scenario with the same interest, but this interest rate now it's compound. The first thing to do there, you're going to say A is equals to P into 1 plus I raised to N, right? And then your accumulated amount will be equal to, how much is the principal? It's 5,000. We have 1 plus, my interest is how much? 0,0375 raised to 3 years, right? And then how much do I get for that? Let me take out my calculator quick. So here I have, boom. Let's fix this. Let me remove this and this. And I raise this to 3 years. Right? I'll get how much? 5583, comma, look at this, 857. How much is that? It is 86, because this 7 is going to convert the 5 into a 6. Remember the rounding off principles, right? So 5583,86. Let's write that down. 5583,86. Let's put the rand symbol there. Let me check if I wrote this answer properly, because 5583,86. Perfect. All right. So you see that now, over the 3-year period, there's a slight difference between the simple interest and the compound interest. So the compound interest gained more money, it accumulated more money, and the simple interest accumulated less money as compared to the compound interest. So let's move on quick. I wanted to keep this video short, so let's do that quick. So it says here 5 years ago, which means we are now in the future. In the future tense, let's say that. English is charming. So now we are now in the future tense. A certain amount of money was invested in a bank. A certain amount. So the starting amount, we don't know it. We know that a certain amount. Let me choose a highlighter for that. This is interesting. All right then. A certain amount of money was invested in a bank 5 years ago. So we have what here? We have the period. Let me choose a pen. Quick. Sorry for that. So what we have is that we have the period, right? So this is my N. I know that it's 5 years ago. I know that a certain amount of money was invested. This was the principal amount then. It was the money before it accumulated some interest, right? And it says the value of the investment is currently 2,000. So the value of the investment is now sitting at 2,000. This is my accumulated amount. Calculate the original amount invested, P, if the interest rate was this much for simple interest and this much for compound interest. So they even tell you that they need the principal amount, which makes things easier. So let's do that. For simple interest, accumulated amount is equals to principal into 1 plus IN, that way. And then do I have the accumulated amount? Yes, right here. I know that my accumulated amount is 200,000 right there. That being equals to, I'm looking to the principal amount. I have 1 plus raised to I. What is my interest? Right here. This is my interest as a percentage. This is my interest rate. So I'm going to write this as 0,05, because you remember you have to write this as a decimal. I'll multiply this by how many years? How many years are we talking about here? 5 years. So I'll multiply this by 5. You see that? Now here is one thing I want from you. The more decimals you have to work with in finance, the more closer to being inaccurate you are. So now I'm going to try to avoid working with decimals, which means I'm going to take this and I divide by this whole bracket. 1 plus 0,05 times 5, that way. Same thing applies here. Don't worry guys, you'll never get this wrong in a test. As long as you are applying the proper maths principles, you are fine, right? Oh wait, what is it doing? Okay, you also divide this side by 1 plus 0,05 times 5. Actually guys, this thing keeps on erasing. 0,05 times 5, that way. So this bracket now, it will eliminate this bracket right there, right? Which means I'll be left with P on the left hand side, and then on the right hand side I have 200,000 all over 1 plus 0,05 times 5, that way. So now for me, therefore, my principal amount value is how much? I'll use the calculator here. The amount I get is 160,000. So let's write that down. Let's remove this. Oh, my calculator is being charged. 160,000. Let's write that. $160,000. So if we invested this amount of money 5 years ago with the simple interest of 5%, we would have invested 160,000 rands for us to get an accumulated amount of 200,000 rands over a period of 5 years. So now let's do the compound interest formula. So same thing here, we avoid decimals. I'm going to say A is equals to P into 1 plus I raised to N, because that's the compound interest formula. And then we are going to substitute what is my accumulated amount. That's 200,000 right there. What is my principal amount? I'm looking for that. 1 plus what is my interest I mean as a decimal, 0.05, right? Close that off, raise that to N, which is 5 years, right? And then now I'm going to divide this side by, I can simply add in those brackets there. I have 1.05 raised to 5. That's the bracket above there. And then what I do on the right hand side, I also do it on the left hand side. So here I also divide by the same bracket. So this bracket now will cancel the bracket above, which means now I'll be left with P being 200,000 all over 1.05 all raised to 5. Therefore, my principal amount value, the symbol means therefore, guys, it's 3 dots. My principal amount value, it is going to be 156,705. 156,705. So 0.23 cents. So let's write that down. Easy. 156,000. Oh wait, I lost that value. Where is it? 705, comma 23 cents. You can also check that with me in case you are using a calculator. People who are not new to this channel, they already know. Once you are watching these videos, it is in your best interest for you to pause the video, solve the questions on your own, and then unpause the video or play the video to see how we solve our solutions. Okay, let's move on, guys. So we do see that now for you, let me remove this here. For you to obtain an accumulated amount of 200,000 5 years ago with the same interest rate, if we were using simple interest for that investment, we would have needed to save 160,000. And then if we were using the compound interest formula for an investment, we would have needed less money to achieve the same results as in simple interest. Okay, so now let's move on. This is probably the last question. This video was meant to be short, guys. Please don't be disappointed. So now for this one, I need you to take note of this statement I wrote in the red bracket. So it says calculating N in grade 10 won't appear a lot in compound interest formula because it needs logarithms, which will actually be studied in grade 12. So guys, please note, I was very careful in my wording there, because wording, not the wording. Okay. It says, oh, let me choose a smaller highlighter. This is terrible. It says won't appear a lot. It doesn't say it won't appear at all. It says it won't appear a lot. So there might be one question whereby the examiner just decides to throw you off, and they want to see your skills in terms of how well can you deeply analyze mathematical or algebraic equations for you to be able to solve this. And we might just throw it in there as a question that's difficult for you to solve at the moment, and then if you win, it's fine. If you don't, it's fine, right? So but then we are saying that you won't really get a lot of questions whereby we ask you to calculate the N in terms of the compound interest formula. So now let's dive deep into this question. It says how long, look at that right there, we already know what is this. How long would it take an investment of, which means the investment is starting here, an investment of 40,000. This is the principal amount. To increase by 5,000, this is the interest, right? This is not the accumulated amount. This is the interest that this 40,000 will gain. If the interest rate is 4.5% per annum, simple interest. Oh, look at that. You see that? So this is how you read a financial mathematics statement or question. You highlight the key concepts so that you can be able to solve them. So here it says how long. We are looking for N, obviously. With an investment of 40,000, this is the principal amount. This is the amount before it gained any interest. And after it gained an interest, so this is the interest, right? Which means now our accumulated amount is going to be the principal amount plus interest. Sorry, Sanji. So now accumulated amount is going to be how much? 45,000. Easy as that. That's the accumulated amount. And then so we know that we are using the simple interest formula. And then we know that this is the interest rate as a percentage. So now, based on this statement of simple interest, I know that I'll have to use the simple interest formula, which goes as follows. Right there. Do I have the accumulated amount? Yes, it's 45,000. Do I have the principal amount? Of course, it's 40,000. I have 1 plus. What is my I? Here is the I as a percentage, the rate as a percentage. So now my interest in terms of a decimal, how much is it? 0.045. Multiplied by what? By N, because I'm looking for those number of years. Right? So let's scroll down a bit. Just a bit. Perfect. So now we are done with the statement. We are done with interpreting the financial mathematics statement. Now what's left is for us to apply simple algebraic equation concepts right here. So firstly, I do realize that I have a problem with this 40,000. So I'm going to start by removing this 40,000, right? So how you solve it, it's really up to you. There's no one way to solve this, but I would rather deal with this 40,000 and get it out of the way so I can open my brackets. So divide by 40,000. I'll also divide this side by 40,000. Remember what you do on the left, you also do on the right. So now this 40,000 will remove this 40,000, and this 3 zeros will remove this 3 zeros. I'll be left now with 45 over 40, in which I can simplify that, but I don't have to. Okay, that is equals to, and then now I'm left with this part. Let me highlight this part in blue. Guys, I wish you would have started algebra with me, but it's so nice. It's so nice. So when you're looking at this highlighted part, the biggest question now is that, is there anything holding these brackets together? Before, this 40,000 was keeping this bracket intact because it would have needed to be distributed here and also be distributed there. But then now, not anymore. The brackets now, they do not need to be there because there is nothing outside to multiply with into the brackets. So which means now I can just simply remove the brackets, right? So it means now I have 1 plus 0.045 multiplied by N, right? So now, which one is more easier to remove? Obviously, I'll need to remove the 1 right there, so that I'll be left with this number next to N. Remember, we are isolating everything from N to the other side and leaving N alone on the right side. So we have 45 all over 40. I transpose the 1 to the other side. Because the 1 was positive, when it gets to the other side, it will become negative, right? That is equals to 0.045 multiplied by N, right? So remember what we said. We are avoiding to work with decimals here. And then if there is a way of me avoiding decimals, I'll take that way any time of the day. So here, what I'm going to do also, is to divide this side by 0.045. Why? I'm removing this value here with this value above there, so that n will be isolated alone. But then remember, what you do on the left, you also do on the right. So which means this whole number here, let me put it in brackets, I must divide it by how much? 0.045. Right? And then moving on, don't worry guys, this is the last question. And then what do I have? On the left side, I'll be left with n alone, and then I'll be left with this whole thing here on the left side, right there. Right? Therefore, let me solve for n. I'm actually going to put on a calculator here so that you guys can see how I use a calculator to punch these values here. Because some people can't really use the calculator the way they're supposed to. Let me say it that way. So I put a fraction, and on that fraction I put another fraction, right? And I'm going to say 45 over 40. I go to the side, then I say -1, then I go to the denominator, I divide by 0.045. Easy as that. Then equal sign, I press from this to decimal. Oh wait, decimal. Here's the decimal. It gives me 2.78. 2.78. Let's write that down. It's rounded off, remember that. 2.78 years. Right? But then this is not rational. Imagine talking to someone saying, you'll pay me this amount in 2.78 years. It's not rational. We don't have conversations like that. That 0.78, we don't say it in terms of years. Maybe in terms of money, yes. We can say money in terms of decimals, but we don't talk about time in terms of decimals. So let's make this statement rational. What's happening here? My period, I have 2 years, right? Plus 0.78 years. So this statement, there is one part that is rational, which is this one. Let me highlight it. There is one part that is rational, which is this one, and there is one part that is not rational, which is this one, right? So now let's fix this irrational part, right? So I'm going to say here, 0.78 years. It doesn't make sense. I'll have to look for 0.78 years, 0.78 of 1 year, and see how much is that. So let's put that in a sentence so that we can remember it from now onwards. 0.78 of 1 year. 1 year, not years. Come on, Mr. Manala. Yeah. And then what else do we have? I can say now 0.78. What does of mean in multiplication? In mathematics, it means you must multiply. And what is 1 year? To rewrite that, well, 1 year is the same as 12 months, right? It's rational for me to move from years to months because this statement cannot fit into 1 year. It's not big enough for it to be a year, so I'll convert it to months. So now, what is 0.78 multiplied by 12? So let's put that there. 0.78 multiplied by 12. I'm looking for months now. What do I have? 9.36. Easy. So I have right here 9.36. Right? So now I'm set. I can leave this in months if the question requested me to leave it in months. If it said leave it in days, I'll also have to develop this decimal to be in terms of days. But now I'm going to do it in terms of years and months. Right? So I'm going to say now, let's round this off to the nearest whole number. How much is this? Well, when I round off this value into a whole number, I look at this value. Right. When I round off the 9 to the nearest whole number, I look at the number next to 9, not the number next to the one that is next to 9. I just look at this one. And then can this change 9 to be 10? No. So which means now I have approximately just 9 as a rounded off figure. So now my answer is going to be the amount of period it's going to take is this 2 years. And what else? This 9 months right here. This 9 months. So 2 years, 9 months. That's the answer to the question we had about them. Okay guys, thank you so much for watching this video. If you lasted up to this point, please don't forget to like the video, subscribe to the channel, and also leave your comments down below for anything that you want us to cover from here onwards. I very much thank you for your patience with us. So keep following the video, and I'll see you on the next one.